Welcome, 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 welcome. Okay. So what we're going to be talking about is we're going to be talking about the abacus. This is the abacus, and this abacus helps me count. So, hi, welcome to my room. Thank you for everybody joining. Thank you for everybody joining. What we're going to be talking about is this crazy thing. This is the crazy thing. This is not really crazy. It's actually really simple to use, easy to understand. This is an abacus and it helps me learn how to count. Not learn. This helps me count, right? So we're going to count 1, 2, 3, 4. Now, why do we want to learn how to do this? Because it's cool. It's the greatest thing next to sliced bread. Welcome, welcome, welcome. My name is Lynette and I'm here as your abacus teacher. So what is an abacus? An abacus helps count tools. It's a counting tool. So what are we going to be doing is the first thing we're going to do is understand how to read the tool. We're going to read the abacus. Then we can go into adding and subtracting, multiplication, division, depending on how long it goes and depending when I'm going to have my dinner. So welcome everybody to my room. Thank you so much for joining me. This is the abacus room. This is the abacus room. And I don't know if anybody else is teaching abacus live on TikTok. Anyways. Okay, so what we're going to be doing, the reason why we want to know this is because there's a horizontal bar. This horizontal bar tells me that I'm counting these beads. 1, 2, 3, 4. It is easy to supertize. Supertizing means what? Supertizing means that if I look at a number like this, I know that this is 5. If I look at a number like this, I know that's 6. Now we're looking at 4. So 4 is 4. Oh, there goes my abacus. 4 is this. So just like I have 4 here, I have 4 here. 1, 2, 3, 4. Now you might be wondering. I don't know if you're wondering. You might be wondering, well, where is 5? I don't see 5. I see 5 on the die, but I don't see 5 on the abacus. Well, on the abacus, the top bead will always be 5. No matter what, the top bead will always be 5. Why is the 5 there? That's just the way that it's designed. So when we see the horizontal bar and the beads are touching the beam, the beads are touching the beam, right? This horizontal bar, this line right here, that is what's being counted. Hi, everybody. Welcome, welcome, welcome. I am talking about the abacus, and this is a counting tool. This is a math tool to help children, adults, and whoever wants to strengthen their math skills, that we can use this. Now, sometimes people might see it in the museum. Other times, there's actually, on the videos, you could see like the kids doing this. That's what they're using. They're using the abacus. The abacus will help do adding, subtraction, multiplication, division. If anybody has any questions, let me know. There's a few people coming in, and I'm just talking about how we read the abacus. Once we learn how to read the abacus, we can actually do adding, subtraction, multiplication, division. So here is my top bead. This top bead is a value of 5. That's all we really need to know. So then what do we do for 6? Well, 6 will be the bottom bead. The 6 is the bottom bead. Why? Because the bottom bead, anything below the horizontal bar, is our bottom bead. This bottom bead has a value of 1. So when we look at it, we have 5, 6, 7. 5, 6, 7, 8. So notice, as I start pushing it through, these beads that are touching the beam is now being counted. Oh, my internet is unstable. This is not good. Not good at all. So, what's after 8 is 9. What is 9? It's just this bead. So all we did was added 5 plus 4 is 9. 5, 6, 7, 8, 9. Thank you so much for the hearts. Thank you so much for the hearts. So if you look, you might be wondering, okay, we know that 5 is up here, right? All the top bead is 5. So this is 5, this is 5, this is 5, this is 5, and that's 5. Okay, great. Now what are we going to do for 10? Oh my God, what are we going to do for 10? Well, if you look at it, if you notice, this is 5. Okay, this is 5. However, it's actually 50, right? 50. So what does that mean? So our tens is over here. Just like how we write 1 and a 0, 1 and 0, this is our 10. I'm in college math and interested in learning this. Fantastic! E-T 1000000. Yes, fantastic. I didn't learn math. I didn't learn abacus till I was like kind of old, and it was quite interesting going down this path. Because why? Because we actually don't need to memorize our doubles. We just need to memorize our fundamentals of abacus. But before we go into the fundamentals of abacus, it would be nice to know how to read it. So we're continuing to learn how to read the abacus, and I'm trying to look for some papers that I have, and I don't have my papers. So I'm just going to use this. What is this for? This is just going to tell me that I'm going to write my number. So just as we talked about 10, right? We talked about 10. So this is tens, right? We know this. We know how we write, right? This is the ones and this is the tens. So when we look at it on the abacus, it's the same way. This is the ones, this is the tens. So when we do that, this is the tens. When we do this is 20, just as we write. 2 and a 0, 2 and a 0. So we have our ones, our tens, our hundreds, our thousands, and our 10,000. Now, you might be wondering, well, why are you starting here in the middle? Well, if you notice, there's a little dot right there. And that dot tells me my place value. So my place value, because it's here, tells me that it's the ones place. You could notice there's 2, right? You could start from here. It's all about perspective. Now, it depends on what we're trying to do. If we started here, it would mean that our number would be bigger, right? We have all these numbers to be bigger. Ones, tens, hundred, thousands, 10,000, right? Or if we put our number here, then this would be the decimals, right? Just like how we write 2.025, our decimal, whoa, that's blurry. Our decimal actually, oh, that's better. Our decimal does not sit on a place value, right? It sits between the columns. So now we have 2, so I'm going to do 2, 0, that's 0, 2, and then 5. So now we have a smaller number. So depending on, that's why we have the difference between the dots. That's the only reason. That's the only reason. So it doesn't even matter where you are with the dots. Welcome, everybody. Welcome. So just like this, here is my 13 column. And it's the same thing. With the 13 columns, this is only 7 columns. So with my 13 columns, notice I have multiple dots. These dots are the separators, right? Just like how we have 1,304 and 705, right? Just like that. If I looked at my abacus, I could do the same thing. 1,304, 7, there's my 7, 0, 5. So notice I have my dots. It tells me where the separations are. So you can either do here or you could do here. It deemed it here. So all of these numbers to be your decimal. It is up to you. We are not here to judge. So let me know if you have any questions. Thank you, E.T. Why? Because when we start moving our beads, I'm going to use a colorful one because I like it colorful. When we start doing it, right, we notice that we can add the 2 and we add the 2 and it's really quite interesting. Anybody have any questions? So we're going to continue to count just to show what it would be like. How do we count on the abacus? So here is 4. How do I know that this is 4? Because if you notice, 1, 2, 3, 4. These beads are touching this horizontal bar. This horizontal bar tells me that we are counting this bead, these beads, these lovely beads. So, and then after 4, there's 5. So we have 5. And then again, we have our dots. So we have 5 and we have 6. We have 7, 5, 6, 7, and then 8. 5, 6, 7, 8, and then 9. 5, 6, 7, 8, 9. Make sure that all the beads are touching each other, right? They're singing Kumbaya and they're all making sure that they're together. Why? Because then we know that there's no confusion whether or not we're counting these beads or not. Because if it's like something like this, then I wouldn't count it, right? The reason why is because it's not touching touching each other. So then that means that this would be 8. So not to get pornographic, but that's what would happen. So talking about this, here is 10. How is that? Because there's the ones and the zeros. So just like here, we have ones and our zeros. So we have 1 and 0, so we have 10, 11, 12, 13, 14, 15, and then 16. How do I know? Because these beads are touching, all these 3 beads are touching. So it's 5, 6, and then 1. So this is 16, and then 17, 18, 19, and then 20. 2 and a 0. Anybody have any questions? If not, I'm going to continue on to doing some adding and subtraction. So that was the reason why I added this book. So this book was primarily for children who started to learn how to read the abacus. And this book goes from 0 to 9. I was kind of guesstimating that the kids that would be using this would be 3, 4, and 5, maybe 6, right? And the idea here was that it was a combination between, understanding what the beads are and what the number is. And it continues on. And then from here, I have it where I would have activities to reinforce what the numbers are. And this is available on Amazon, and you can find it through my name. My name is right there. You can find Lynette Young, and you'll find my books. You'll find my books. Okay, so just as we're going through this live, it's the same thing with the book, right? You need to understand how to read the abacus. So as we read the abacus, 1, 2, 3, 4 is what we were doing with this. But we don't need to know the relationship for the numbers, because I'm assuming that everybody understands the relationship of the numbers, right? So, but to go further on in the book, we talk about counting forward, right? Counting forward and then counting backwards, and then finding what happens in between and what number comes in between and what numbers is surrounding. So those are the different relationships that the numbers can have, and they're focused on abacus. Because you can find a lot of other books, but they're not abacus driven. This is specific abacus and talks about how to learn math with an abacus. So that's why I have a lot of pictures of the abacus, because I wanted them to relate between the picture, the physical, and the physical toy, physical item, physical tool, and the abstract, which is the numbers. So again, thank you everybody for liking and enjoying. I'm hoping everybody understands what I'm talking about. If you have any questions, let me know. And I appreciate you guys all sharing my lives and liking my live. I do appreciate it. I do. So here, my one question is +1 thumb up. Now, what I'm doing here is I'm going through the process of adding. Right? When we do the process of adding, we want to be able to know, what do we do with this number. In school, I noticed we actually focus in on the result. What does that mean? Well, what does that mean? What does that mean, focusing on the result? Well, I was doing research. So I have 3 boys, and they all gone through the abacus curriculum, the abacus method, and I never really had to help them with their math. So, so I was researching to try to figure out how to relate math to regular school, to just to get an idea. So one of the videos that I was coming across was, the question was 5 plus 3, and we know the answer is 8, and they're really focused on this answer. Thank you for teaching us. No, thank you for joining. Let me know if you have any questions. I appreciate all the questions specific to abacus. Let me put that caveat. Let me know if you have any questions. So here is the question that I found in the video. And the video was 5 plus 3. So I'm going to add the 5 and I'm going to add the 3. That's easy, right? That's what we did for the abacus. I add the 5 and I add the 3. Okay, not a problem. I understand that. Not a problem. That's fine. But they were focused on the 8. And they're like, oh my God, yes, it's 8. Yes, it's 8. They weren't that. They weren't that connecting. I don't know if you guys can see me. Okay, so I'm back. So notice, do I have enough beads to add the 1? Yes, I do have enough beads to add the 1. So what are we going to do? So the answer is 8. How do I know that this is 8? Because it's 5, 6, 7, 8. And again, the reason why I'm counting this is because these beads are touching this horizontal bar. Thank you for the follow. Thank you for the follow, and thank you for liking the live. So here we have 8. We have the horizontal bar, which is what tells us what's being counted, and then we have 8. 5, 6, 7, 8. So here is my answer, 8. So again, the video was all about like the result, but it gets a little hairy to the next one. Well, the question wasn't named Harry. It was just a different way of thinking things. So what does that mean? Well, I'm going to continue on. We have 4 plus 4. Now in school, they have strategies. In school, we are taught to memorize our doubles, right? We could do 4 plus 4 and then plus 1. No, our doubles plus 1. The other one was doubles plus 2. That's okay, right? Or no, doubles plus 1, doubles minus 1. That was a strategy. Well, in abacus, we actually don't memorize our doubles. What we memorize is the foundational item, the foundation equation, the foundation formula. What does that mean? Well, if you notice, I'm going to add my 4, and notice I cannot add any more beads. What does that mean? Well, in school, Now, here's a whole story. This is where it's all coming up. In school, we're teaching the children that 4 plus 1 is equal to 5. We're teaching the children how to make a 5. That is fantastic. That is great. We are going to learn 1 plus 4 is equal to 5. This is a little elementary, right? But we need to know this. Why? Because in Abacus, we're going to take this and we're going to step it up a bit. We're going to step it up and we're going to actually utilize it for what it is. Now, in school, we stop right here. We only say, you know what, this is how you make a 5. That's all you need to know. This is how you make a 5. That's it. But in Abacus, we actually start utilizing this 5. Now, to be able to utilize it, what we're going to do is we're going to isolate the variable. I'm using really big math terms, but in Abacus, we don't use anything like that. So, the terminology is, the math term is, we're going to isolate this variable because why? We're looking for this plus 4 and this plus 4. It's the same. So because it's the same, what we're going to do is we're going to rewrite this question. Okay, we're going to rewrite this number sentence. We're going to rewrite this number sentence. 2 plus 4 is equal to plus 5 minus 1. What did I do? I took this 1 and I moved it to the other side of the equation, right? I moved it to the other side of the equal sign. Now, in Abacus, we call this a formula. In mainstream math, we call it number sentences, right? This is a addition sentence. I'm assuming this is a number sentence. I'm not sure. But again, what I did is I isolated the variable, and then what I'm going to do is I'm going to substitute this equation, I'm going to substitute this formula into here. Now, the reason why I have plus 5 is because I wanted to have a gentle reminder that we're going to add the 5 and we're going to take away the 1. That's what this means. I'm going to add the 5 and I'm going to take away the 1. So here I have 4. I don't have enough beads to add the 4. How can I add the 4? How do I add the 4? Well, I'm going to plus the 5 and I'm going to take away the 1. And then my answer is 8. So in Abacus, what we do is we memorize the process. We memorize the formula on how to do it. We understand the process to get there. So then now my answer is 8. Now we can all celebrate. But the way I have it, especially here, is we talk about the add-in. We do the add-in, we understand how it moves, then we can go into understanding how we get the answer. So the focus on Abacus is we need to know the process and not the result. And that's why it's different. Because then in elementary school, we teach the kids to go to the result. But then we have to backtrack when we get to like the higher maths, like algebra or calculus, and we need to understand the process, which is interesting. Like it's an interesting perspective. And in Abacus, we actually do is we focus on the process and we go through it. It will take a little longer to understand this part, but once it's understood, once they figure this out, it goes into long-term memory. It's easier to grasp. So coming back to here, these questions are really simple. We're adding 1. Well, why are we adding 1? Because we want to show the reason why. Can you please explain the sentence with the plus 4 as a variable? Oh, okay. So, okay, yes. Oh, okay, you know what? I'm going to continue on with this one. So let me continue on with that. Because what does that has to do with anything? I'm trying to find my book. Focus. Okay, got it. I got it. So here's what I'm talking about. Now, as a child, I'm not going to say isolate the variable, right? But because I'm talking to adults and to understand what we're trying to do, I wanted to talk about isolating the variable. So when we go to school, we teach the children how to make a 5. And so one of the ways to make the 5 is 4 and 1 is equal to 5. Right? These are multiple things that they teach. So they use many things to teach how to make a 5. The only thing we're doing is we're trying to make a 5. So we have 1, 2, 3, 4, 5, and then we don't need these, right? So we know that if we do 4 and 1, it's 5. If we do like the other way, 1 and 4 is 5. Not a problem. But now that's as far as the Abacus, that's as far as mainstream math will go. Now what I'm going to do is why do I want to isolate this variable? Because it's a formula. So what I teach the kids is I don't teach them, how to isolate the variable. What I teach them is the formula. Plus 4 is equal to plus the 5 minus 1. So why? Because because we did this one, right? We did 4 plus 4. Let's take it one more step. Let's do 2, right? We do 2. And I want to add the 4. Now, the question is why do I want to add, not why, how can I add a 4? I don't have any more beads. In order to add a 4, we need to use the formula. Plus the 4 is equal to plus the 5 minus 1. Well, how are the kids going to know this? Because one of the things was after the preschool book, they will graduate into doing, adding with the 5. So I put it into a place where the kids would have to remember a little story. And the little story is there's 5 cats in a tree because cats like trees. And that was the reason why. So I said, okay, let's talk about this. We want to add the 4. What are we going to do? We need to go to the cats in the tree. There's 5 cats in the tree. 1, 2, 3, 4, right? We're going to go to the 5 cats in the tree. We're going to add this tree. Notice that? Do you see how I added the tree? I'm going to grab 4 cats. And then 1 cat runs away. That's the minus. I'm going to take one away. So then my answer is 6. So when I would explain it to the children, that's how I'd do it. I'd say, go to the cats in the tree. There's 5 cats in the tree. I'm going to add the 5, right? I'm going to grab 4 cats, and then 1 cat's run away. And that's how I get 6. So my answer would be 6 here. Let's take it one more. Let's do 3. 3 plus 4. So I have 3, and I'm going to add 4. When I add 4, is there enough? If you look at the abacus, that's the question, right? In abacus, we have conversations, right? The conversation is there enough? Can I do it? Right? Whereas in school, we don't have conversations. We're just expected to do it. But I think in math, you need to have a conversation to see, well, if I can't do it, how can I do it? And it lays the groundwork of doing like algebra and calculus and so forth, because now we're starting to build more of an analytical, critical thinking when we start looking at our stuff. So here, I want to say, how can I add a 4? Well, we know if we add a 5, we go to the cats in the tree, we add the 5, grab 4 cats, 1 cat runs away. So then my answer is 7. Does that make sense? Did I answer your question? I have to go back. Vermilion. Okay, great. Let me know. Oh yeah, great. Let me know if you have any questions, and I will always backtrack. Because there's no point of keeping going forward if everybody's lost. So, but that was the thing, like, keeping track. Because I was gathering that the kids would be young. So that's why I made a story. So because of the story, I talk about, and I would use my hands. I would use my hands to be like, okay, you go to the cats in the tree and you grab 5. Because we have 5 fingers. I'm hoping we all have 5 fingers. If you don't, then you can use items. So that was the other thing I noticed, right? In school, we're starting to use manipulatives. And it's great. Like, manipulatives, I think, are great because I think it's great that we show the kids how math is being used, how do we get items and so forth, right? But it's interesting that we don't think about using this museum piece because it's interesting, right? Like, it makes it very simple what we're trying to do. We don't talk about quantity here, but we do talk about place values. So the place values is the ones, tens, hundred, thousands, 10,000. You could do it here, but it would be very big. It'd be a lot, right? And it's a little bit too much. So like I have all of these number blocks. So the number blocks are being used, and it's great. It's fantastic. You know, Abacus doesn't talk about the numbers. We just talk about how we would translate it how we would translate it. So it's fine, right? We could do it if you want to show quantity, or we could also show how we move the beads. So it depends on where you want to go. It'd be great to graduate from knowing the quantity to understanding how to move the beads. Wait, abacus is like tally marks with a blue bead. Yes, exactly. Carbonated ren. Yes, you know what? Somebody did mention that, the tally marks, and then when it's all crossed, and it's exactly what it is. Exactly. So our tally marks, in case in case people don't know what it is, tally marks 1, 2, 3, 4, and then 5. This 5 is the top bead. Exactly, exactly. But we don't break this up. Okay, just so you know, we don't break this up. You can't break up this 5. What you can do is rearrange it so we can use it. So that's why we have this. So when we look at our formulas, there's another way to make a 5. What's another way to make a 5? 3 plus 2 is equal to 5. And again, 5 plus 2 plus 3 is equal to 5. Same thing. So just like we did here, we can isolate this variable. So there's a whole list, there's a whole formula list that we need to understand. So let me take this one step further. I'm going to have plus the 5 plus 3 is equal to plus 5 minus 2. Same concept, but different number. Let's see, let's isolate this variable. Plus 2 is equal to plus 5 minus 3. And then the last one is plus 1 is equal to plus 5 minus 4. Now the reason why I have these the reason why I have these operators plus, right? The reason why I have this is to remind us what we're trying to do with the beads. So when we look at it, let's say we do, let's say 4 plus 3, right? 4 plus 3. Plus 3 is what we see. Do you see how there's similarities? So now we isolated the variable. Now we're going to substitute this formula into the question. So now we're going into the next step. The next step is to understand, wow, hi, good morning, lady. I think it's morning time for you. Thank you so much for the rose. I see you. Thank you so much for the rose. So now we isolated the variable. We're going to substitute this formula into the question, right? So when we have it, we have 4. Now I'm going to substitute plus the 5 minus 2. So I'm going to add the 5 and I'm going to take away the 2. So it's the same thing. I go to the cats in the tree. I'm going to add the 5. I grab 3 cats and 2 cats run away. So then my answer is 7. Yes. Yeah, right? It's mind-blowing. Like, there's silence, but it's really simple to use, easy to understand. And yeah, I heard that and I'm like, you gotta be kidding me. So here, all my life, I had to memorize doubles and strategies and all this and that. Whereas in Abacus, if you learn how to make a 5, if you learn making 5, then you're halfway there, right? The next one is to learn how to make a 10. So I don't know if everybody's okay with me continuing on with learning how to make a 10 or if we continue on how to make a 5. Because when we make a 5, since we know how to add the 5, we have to take away the 5. Like wax on and then wax off. Yes, okay, great. So I was on live earlier and somebody called me Mrs. Miyagi and it was hilarious. And then I started talking about waxing on and waxing off and we were talking about painting the fence, right? You paint the fence up and you paint the fence down. So what did we do? We painted the fence up. So this is what adding the 5 is. Now let's paint the fence down. I'm going to start using it. That's fantastic. My God. You know what? I really do enjoy all of these lives and TikTok lives because the conversations that we have is fantastic. It adds so much humor to my little abacus stuff because this is fantastic. I want to tell you everybody that I appreciate everybody who comments and who join my live because it's hilarious. So we're going to paint it down because we painted up. Now we're going to paint down. What does that mean? So just like we did, right? Plus 1 is equal to plus 5. Now, let's say we do the reverse. If we do the reverse, we're going to assume that there is a plus here. I'm always playing around with this stupid camera. Okay, so we're assuming that there's a plus here and a plus here and a plus here, right? Now there's a minus. So there's a minus 4 minus 1 is equal to minus 5. Is this a negative? No, not really. Not really. We don't do negatives. We don't really do negatives on the abacus. Because you can't really do a negative. You can't really do a negative on blocks. You can manipulate it, but then it gets confusing really easy. And I was thinking about it. Anyways, so again, what are we going to do? We got to isolate the variable. When we isolate this variable, why do we want to know how to minus a 4? Well, just like we have another question, right? Another question. Let's write my question. So my question is, let's do something simple, right? 8 minus 4. Notice I have a minus here. This minus would be here. So now I'm going to isolate my variable. I got to take my minus 1 and I got to put it to this side. Okay? Makes sense? So now I'm going to rewrite my formula, and this is the formula that we need to memorize. Minus 4 is equal to minus 5 plus 1. Make sense? So once we know this, we now are painting, right? Because we're painting, we need to understand that if we paint on, we have to paint off. We paint up, we paint down, right? So now we know the difference. So now what I'm going to do is I'm going to substitute this into here. What does that look like on the abacus? So on my abacus, I have 8. And then I need to take away the 4. I cannot take away the 4. If I can't take away the 4, what do? Now what I do is I have to go to my 5. I minus my 5, but I need to add the 1. So now my answer is 4. There we are. Plus 4. Or add 4. Just 4. Just 4. So then it goes into a whole slew of, like, once we understand how to add it, we need to take it away. So now when we take away, there's a set, right? Just like there's a set of plus, there's a set of minus. So minus 3 is equal to minus 5 plus 2. Minus 2 is equal to minus 5 plus 3. Minus 1, da 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 da, right? Minus 5 plus 4. Right? So now we see patterns. And that's the interesting part, right? The interesting part, if you look, it's this bead and this bead. So when we add the 8, when we're adding 8, we want to move the bead. This is the bead we're moving. No, these are the beads we're moving. This one and this one. And see how we're moving up and down. This is when we add the 5 and take away the 5. Add the 5, take away the 5. Add minus the 4 plus the 4. Minus the 4 plus the 4. And that's a number pattern. That's a number pattern that, we teach kids to look at for number patterns, but we never go through with it, which is strange. Oh, yay, I get to go to science camp. Yay. My last time to go to science camp. Sorry, let me focus. So that was the interesting part about adding and subtracting the 5. If you'll notice, there's a number pattern to go with it. I'm using 2 fingers to really demonstrate the number pattern. Usually I would use one finger. I'd use one finger, the middle finger, not the middle, the index finger and my thumb, and I just go up and down. That's what I do, up and down. And then it's the same thing with the 2 and the 3, right? If I want to minus the 2, minus the 3, if I have 8, no, I can't do 8. I do 7. If I do 7, minus 3, it's these 2 beads. So it's these 2 beads they'll always be in sync. It's always these 2 beads to know. Okay. If there's any more questions, I am going to head out. It was a short one because I'm going to go for dinner. I'm a math interventionist. I am intrigued. Oh, awesome. We only use Rec and Rex. This is the whole other beast. Woo, Rec and Rex. I know about Rec and Rex. I kind of know of Rec and Rex. And I was like, you use Rec and Rex. Why don't you use the abacus? What about me? I feel like the abacus is like the stepchild of everything. Yeah. You know what? Keeks, if you want to talk more about abacus, I feel like, using the abacus would really help with intervention. I just haven't figured out how to get into the mainstream stuff. So that's why I'm here. I'm here to try to introduce abacus to the world of TikTok. But I do believe, I've been going down this path of trying to figure out how to do certain things. And some of the things that we actually don't say in abacus is we don't call it isolating the variable. We don't call it number sentences. We call it formulas, and you just push it all together and you take it all apart. And as you understand how to add everything, we know how to take away stuff. So as we start building, it was really quite interesting. For us in abacus, we only need to know 2 sets of formulas: how to make a 10 and how to make a 5. If you know how to do all of that, then everything else is gravy. It doesn't even matter how big the number is, and it doesn't matter how many add-ins you have, because once we have all of that, because we can put it all on the abacus, and the reason why we use the abacus this way is because we can use our place values. I know with the Rec and Recs, they go this way, so it's harder to figure out where the place values are. So I feel like that this is more leaning towards understanding. Gave you a follow. Will definitely continue to tune in. Yes, fantastic. Let me know. I'm really quite curious about the whole intervention stuff, because I feel like, but you know what? I want to take it one step further. It shouldn't have to be what kids like it being in, having intervention, right? What I wanted to do was I wanted to show how it can be used in mainstream math, because it's just that it is just that it's just that great. It's just as great as, sliced bread. So my boys all know the abacus method, and they've gone through it. Do they ask me questions? No, they don't ask me questions about math or anything. They're pretty solid. I know when my kids were going through algebra, they were like, this sounds vaguely familiar, but I don't know how I know this, because I don't know algebra. And I go, the reason why you know algebra is because you know abacus. And there's a way how we do things in abacus that's very similar to algebra. And what we do in abacus is we talk about the process and not the result. So, Keeks, if you have any question, let me know. I would love to, talk about how you do things and how everything is working, because it's really quite interesting to see how to help the children to be better at math. And I feel like using the abacus helps fill in the gaps that we miss as children when we go through school. So like I was talking about learning the doubles. We do a lot of strategies, and I feel like that it can be boil it down to understanding just the fundamentals. If we can understand and break it down. Good. Hi, Audrey. I'm back. Keeks, I was just saying, I feel like that we complicate math a little bit too much, and I think if we can boil it down, it will be easy to do certain things. Because there's a lot of things like, how to make a 10. If you had like three numbers, oh, how do we, make it into a whole number of 100s and so forth. And there's a lot of like manipulation. Whereas I feel like if we just know the fundamentals, how to make a 10 and how to make a 5, everything else will fit in. Everything else will fit in nicely. So. But I do have to go. Thank you everybody for joining. It was a short one. I do appreciate it. It's 40 minutes. I'm still I the husband's like, "No, you can't go live." I go, "I just want to go live for a little bit, cuz I just wanted to get out there and just try to get out there and just, talk about how great Abacus is and how wonderful it is." But yeah, let me know if you have any questions. You come through questions and I'll go through how I do it on the Abacus, and we can talk about it. Ooh, maybe we can have a combat. I don't know, like a little powwow, a matchup, right? That would be fantastic. But again, thank you so much for joining. Thank you again for everybody commenting. This was fantastic. I'm going to go have some dinner. So it's still 7. I will be on later tonight. I found you on the tail end, so I need to learn before commenting on the method. Okay, let me know. You know what? I am planning to go. I am planning to come on later on tonight. Probably give me about 3 or 4 more hours, and I'll be on. So if you follow me, you can. I think the notifications whenever I go on live, you'll see. So it'll be good to talk to you then. But yeah, it'd be good. I know. I just find that abacus is the greatest thing next to sliced bread. I don't know Rec and Rec very well, but I know of it. But I do feel like that this would lend itself very nicely to multiplication and division. Just so you know. And we can go into that too. And then we also do decimals as well. So we also do decimals, but we don't do fractions, because fractions is just another way of doing division. Right, Audrey? I remember you said that. I was like, yes, fractions is just another way of dividing. So, all right. But yes, thank you again. I will be on later tonight. It was just, this one was a quick one because I just kind of want to pop in and say hi to everybody. And thank you for joining me. Thank you again for joining me. It was just one of those things like, thank you again. I do appreciate it. And I will see you guys in my next live. Bye, everybody.